Okay, well, welcome everybody to Solar Noon Tuesday. And we'll start out with some of the news here for this week in the solar industry, the week of May 15th. So the Tennessee Valley Authority announced that they're looking to more than double their capacity for solar within that particular operating region. In fact, their news release said that this is the nation's largest request ever for clean energy. Currently, TVA has about 1.6 gigawatts of solar capacity within their operating region. They plan to place bids and install about 6 gigawatts over the next 3 years. That'll be about 40 projects. And by 2035, they're looking to install about another 10 gigawatts of solar. And the TVA, in case you're not familiar with it, it's a federally operated utility. Serves about 9 million customers. It's in Tennessee, parts of Alabama, Mississippi, Kentucky, Georgia, North Carolina, and Virginia. So a lot of things happening there. Our buddy West Virginia Senator Joe Manchin just introduced a bill on May 2nd to try and reform the permitting and interconnection process within for generating capacity within the grid. Currently, it takes about 5 to 10 years for one of these permits to be approved through this process. So the bill stated goal is to try and streamline this. One of the things they're doing is setting a 2-year limit on what is referred to as the NEPA review. And the NEPA review has to do with the National Environmental Policy Act. So they're putting a 2-year limitation on that review process. And for those systems that are deemed to be low impact, they're putting a 1-year limitation on that review process. Then they're also limiting the amount of time that's available for court challenges to these approvals or non-approvals of the different connections. So as a result of this bill, about 290 environmental groups have written a letter to the Biden administration protesting or saying that they're opposed to this particular process or bill. They're saying that this is a giveaway to fossil fuel industry, that it's a big windfall for the fossil fuel industry, doesn't help renewables very much at all. They would rather see a wholesale reform of the entire permitting process with a greater focus on energy conservation and distributed energy systems. I think that's one of those situations where you go, yeah, everybody would like to see that. Is it possible to achieve? Then the White House has said, well, we don't love this bill, but we're going to support it because they think it's better than nothing. It is interesting to point out that even though the environmentalists are saying this is a thing that's a big windfall for the fossil fuel, about 95% of all of the projects that are awaiting approval that have been delayed are renewable energy projects. So the vast majority of projects that would be impacted by this bill are in fact renewable energy. The jury has awarded a couple in Georgia $135.5 million on against a Tennessee-based solar developer called Silicon Ranch Corporation and an installer, IEA. And basically, the bottom line behind why this was awarded was that this is a 100 megawatt, 850 acre project down in Georgia. Now, before they began developing this project, apparently there was a lot of concern about stormwater runoff. And this area, this particular area, is a hunting and fishing location. That's what it's been primarily used for, recreational hunting and fishing. Then they promised all the adjoining properties they would indeed mitigate stormwater runoff. They came in, they clear cut about 1,000 acres. They did nothing to try and mitigate any of the soil erosion or stormwater runoff. And so silt, soil, sediment flowed into all of the adjoining properties, apparently filling up lakes, fishing lakes, trophy fishing lakes that were adjacent. There were a lot of complaining. Nothing was done for a couple of years. So it went to court, and the jury found $10.5 million in compensatory damages. Basically, that's how much the adjoining neighbors were damaged. And then $120 million in punitive damages. So quite a reaction there. And there was a study by Northeastern University recently. A study was called the Environmental Research, Sustainability, and Infrastructure. And what they did find, which I found was kind of interesting, is that the roof space on factories and warehouses actually could accommodate enough solar in a distributed manner to serve up to about 35% of all of the industrial electrical needs in this country. So just locating these on the roof space of the factories would provide up to 35%. Now that's significant because currently the industrial sector uses very, very little renewable energy. Currently, less than 0.1% of all of their electricity comes from solar. So this is a big opportunity for expansion. We've seen a lot of utility scale expansion, a lot of commercial, even a significant amount of residential. The industrial has lagged far behind, but there is a large potential for this. And that's the news from the solar industry for this week. So anybody have anything they would like to add to that? And I'll just remind folks, if you do speak up, if you can turn on your camera, that would be very helpful. So anybody have any news to add to the mix? Give you just a second. All right, while you're thinking about that, or even if you're not thinking about that, I will give you some of the events for the upcoming week. Or not the upcoming week, but things coming up in the upcoming weeks. There's a webinar May 17th, which is tomorrow at 1 p.m. Eastern, on smart electrical panels. This is an area that's going to become more and more prevalent, where we start to see the service panels, where your circuit breaker boxes begin to have intelligence built into them, so you can deal with load management, things of that nature. So there's a webinar on that. At 2 p.m. tomorrow, there is an IREC meeting. That's the, what is that? The Interstate Renewable Energy Commission, I think it is. Anyway, they're doing about workforce development, workforce insights. That's available at 2 p.m. Then 6:30 p.m. you can spend all day tomorrow on webinars if you want. There's a community solar town hall meeting that's available through Solar United Neighbors. And then on the 18th at 2 p.m. there's a webinar on UL 3741 standard. This has to do with understanding the limitations of module, of trying to deal with rapid shutdown without module level power electronics. So that's something that's hanging out there. 18th at 8 p.m. there's a Solar United Neighbors webinar about if you've now installed solar, what next, about maintenance, about dealing with those kind of things. On May 24th, Reuters will have an event on Europe's response to the IRA, to the Inflation Reduction Act. Seen a lot of news articles where a lot of countries are looking at this as a great success story, and how can they emulate what the US has done within the IRA. May 24th at 1 p.m., there's a webinar about cybersecurity on the grid. And then June 6th, sorry, there's they're touting this as a navigating the changing landscape of solar regulations and standards with NEP. Now, NEP is Northern Electric Power, I think it is. So my guess is there's a fair amount of product specific information that'll be on this particular webinar. And that's, there's a bunch of them. So that's what's I have in the news. Again, anybody, before we get into the main topic that I brought up for discussion, does anybody have anything they'd like to add into the mix, events, news, or even questions that they've run into out there in the field questions they want answered. Give you just a second to pop on in. Everybody's shy. Okay, well, if you want to just
here. Wait a second.
Yeah, hey Bob.
I'm not going to say the right words for this, but maybe the solar panels that are using reflections off of the roof.
Yeah, the bifacial.
Bifacial, that's the word I was looking for, yes. Do they actually work? Because I think that there's some issues as far as what kind of reflective roof you have. And the way they rate them are so high that I don't believe it. So I advised the person recently to not use the bifacial, but use the monolithics.
Yeah, I tend to agree with you. It depends on the roof structure. Bifacial got a lot of play in recent years because when the tariffs for Chinese panels were first introduced, they forgot to include bifacial into that tariff structure. So they ended up being cheaper than just regular solar panels for a period of time. Now that's been fixed and they're still subject now to the same tariffs as the others, but they got very popular. Well, the people who manufacture them will claim you get what, 15% more production or something for just a small amount of
They're
cost.
going up to 535 watts.
Really? So, yeah, clearly for a flush to roof system, you know, one that's just a few inches off the roof following the line, I don't see how they do anything if it's a flush to roof, because there's no way for the sunlight to get underneath the panels. It's not going to reflect back. But for a ballasted system, you know, like on a commercial roof, you will get some reflection back up under. But I think primarily if you have a white roof, you know, something that will reflect sunlight and create a little bit of that. The bifacials mostly are used for things like solar canopies, solar walkway areas, ground mounted systems that are over snow or sand. That's really where they can perform nicely.
Yeah, but this person said, "Oh, I'll paint the roof white."
Yeah, but is it a flush to roof system or is it a
ballasted? No, it's a flush to roof, yes.
Oh, then it's useless.
Not flush, but it's like 3 inches above it.
Yeah, no, that would be useless. You get nothing out of that. Yeah. Maybe a fraction of a percent. It's not worth it. It's
but even if you paint it white, I said so. On the endurance of life, a solar panel might last 30 years. A roof might last 17 to 20 years. And if you paint it, that might last 5 to 6 years.
Yeah. Yeah, that sounds like you gave them the right advice. I wouldn't worry unless you got them cheaper than regular, you know. I mean, if they were cheaper, why not? But it's not going to cause any problem, but it's not going to help either.
No. Okay, so good. Thank you.
Right. Any other questions out there? All right, let me, I had a couple of people this week ask me some questions that revolved around voltage drop, voltage rise. Even, I don't know if Wally is on the call here, but we had talked about, are there limitations to the distance you can go before you hit your transformer? You know, and basically because, you know, the voltage drop, which then the converse of that is voltage rise. So I thought I would touch on this just to let people get a better understanding, hopefully I won't confuse people, as to how this does affect your design situation. So first off, what is voltage drop? And that is the loss of voltage over distance due to resistance. You know, the analogy there is that if you're taking a water pipe and that the power is the pressure that it's operating under is the voltage, over distance, the friction of the water moving along the side of the pipe will cause the pressure to decline. Well, over distance, the friction or the resistance that the wire imposes upon the electrical signal will cause voltage to decline. So the voltage drop equation for solar is voltage drop equals amps, in this case, the IMP, the operating amperage of your solar array, times resistance, and you get resistance out of the National Electrical Code, and it's usually given to you in ohms per 1,000 feet. And then you have to say times twice the distance divided by 1,000 feet. So you're saying how much distance, how much of 1,000 are we dealing with? And we say twice the distance because the wire is a circuit and it goes there and it goes back. So the electricity is traveling twice the distance. So if you've got a 150-foot run, the electricity is actually traveling 300 feet. And that would be 0.3 of 1,000, and you multiply that times the resistance. Anyway, there are other ways of finding out that voltage drop, but that's the concept behind it. How do we get rid of voltage drop, or how do we limit it? Well, you can't get rid of it. It's just going to be there in some form. But shorter distances for your design, if you can keep your distance as short as possible, which you probably want to do anyway, just because it'll save you money on your installation. But reduce the distance. That's often something you don't have control over. Putting in bigger wire, that's the thing that everybody does. But of course, bigger wire is bigger money. So it's going to cost you more. Better wire, use copper versus aluminum. That's primarily your choice. And higher voltages. The higher the system voltage, the less impact voltage drop has on the system as far as a percentage of loss. Doesn't change the amount of voltage drop, but it does change the percentage of power that's lost due to voltage drop. So the purpose of this wasn't really get into the whole idea of how to calculate voltage drop, how to mitigate it, other than you just know you throw in bigger wire. That's usually the thing. So I thought there's an interesting calculator. I've got the web address of this voltage drop calculator there on the screen. Or if you want it later, you can contact me. But if you just Google voltage drop calculator, that's a nice little tool there. I'll give you just a second to jot that down if you're doing so, or take a picture of it. And anyway, I'm going to jump in. This is kind of like what the calculator will look like. You plug in copper versus aluminum. You select the size of the wire. There's a pull down menu there. In this case, it's single phase. And I'm making the assumption on this particular example that it's microinverters. 240 volt is what we're going to start with. And it's 150 feet. And it's a typical N-phase 20 amp circuit. So this is what I did there. And you'll see that if you look down below, you click to calculate, and it's telling me I'm going to lose 11.85 volts over that particular run. And that's going to be 4.94% of power. That's my power loss due to voltage drop. Pretty significant, but it's 12 gauge cable. So we're talking about 12 gauge cable there. If I decide to upgrade and put in 10 gauge cable on this same run, everything being held the same except for the size of the cable, now I've lost 7.46 volts. Now it's only 3%, 3.11 versus the 4.94%. So that's an example there of just how impactful changing the size of your wire is. Another thing we could do is say, all right, let's say that this is a solar edge system versus an N-phase. Well, the voltage that's gone up is 350. It's going to be operating at 350 volts, not at 240. Well, it doesn't change the voltage drop. Notice for 10 gauge cable, it's still 7.46, and up here it was 7.46 voltage drop, but it's a lower percentage of the amount of power that's being lost. And then if we go to 600 volts, like for a string inverter of some sort, well, it's still the 7.46 volts, but it's only 1.24 percent of the power loss from start to finish. Excuse me. So that's kind of where we are with voltage drop. But what does this mean as far as what problems can you get into? Well, typically, if you are seeing voltage drop on your system, it's a money thing primarily. We are just saying you're losing 5% of the output of your array. Well, that's not great. I mean, let's say if you just spent $20,000, 5% of that is going to be, what, $1,000. So you just lost $1,000 due to voltage drop as far as the value of the output of your array. But other things that you've seen when you see voltage drop is dimming of lights, motors running not at their peak efficiency. So it can cause wear and tear on some of the load structure within your system dealing with that voltage drop. Well, let me give you an example at Blue Rock Station of a thing we refer to as voltage rise, because voltage drop means that from the time I'm generating my power to the time it is received at the load, basically, I lose a certain number of volts. Well, with your inverter system, the inverters want to match the grid voltage exactly. But if you're losing, say, 10 volts from the time it leaves the microinverter to the time that it hits your service panel, then that means that your inverter has to generate power 10 volts higher at the source than what is going to be received in order to match the voltage of the grid. So your inverter is going to be operating at a higher voltage level just because of voltage drop. And inverters have voltage tolerances. If it's too high, you can actually turn off your inverter. But if you're operating at a higher voltage than, it was really designed for, even though it's still working, it's working harder and it may not last as long. So let's give an example here with Blue Rock Station. I have microinverters on my solar array there, and 6-gauge wire running from the microinverters, a 40 amp circuit here, about 130 feet from the array to where it connects in to the grid. So if you look down below, it says I'm going to be experiencing somewhere around a 5-volt voltage drop. Well, if I go to my online monitoring system, and I will just point out for everybody who's paying attention there, the one panel in the upper left, the microinverter just kicked the bucket. So Enphase has sent me a brand new microinverter, which I'm quite pleased, but I haven't replaced it yet. Anyway, but notice down there at the very bottom right-hand corner, what is the output voltage of my microinverter? It's operating at 245.5. All right. So because of that 5-volt drop, I'm going to be having to kick out at 245.5 just to match the voltage at my service panel. That's fine. That's certainly within the tolerance of an Enphase microinverter. But it's also not that much of a voltage drop there. And I'll point out a few things here in just a bit, but just to tell you that the national grid, and we're talking about the United States here, the US grid operates within certain tolerances. Now, they say plus or minus 5% is perfectly normal. That's because you can't keep it truly steady, because every time somebody turns on an appliance or turns off an appliance, it's going to affect the voltage on the system minutely. So it's always operating within a range. Well, in this particular range, if we're talking about a residential environment, single phase, 240 coming in, the range tolerance that you can see in column 1 there is that the system will typically operate between 228 and 252 volts. So that's normal grid operation. They have another layer, they call it their utilization area, but basically it says for brief periods of time, the grid can operate at a -13 and a +6. So it could veer outside of that plus or minus 5 for just a brief period of time, and it's still not going to shut down. So in that case, now we're down to say about 209 and all the way up to 254 volts, and it will still operate there at some point. And the NEMA for operating appliances and the like say that your appliances should tolerate a plus or minus 10% and still function. But obviously there's a sweet spot that they want to operate within. So that's pretty much what we're talking about there for motors and the like. So hopefully your refrigerator won't be damaged if it's operating anywhere within a plus or minus 10% of its nominal operating voltage.
Jay.
Yeah. Yeah, Joe.
When your Enphase died, you were what, using the M250s?
Those particular ones are the 215s.
Okay. So what did you get back in replacement?
I got back a 215,
Okay.
but it's a brand new IQ 215. I guess
Oh,
they
really?
just manufacture them to replace all of the embedded base of things
So
that are
I've got
out there.
Right. So I've got M250s. So
Yeah.
if one of mine were to like break, what would I be getting back?
You get an M250, exactly what you just
okay.
lost, but it would be a newer model. And
Mhm.
what I found is this is the second one of the 215s that's bit the dust for me.
Right.
And that was one of the criticisms of the 215s, is that they tended to malfunction over time.
Right.
But the new one that I got operates very much better than the older ones.
Nice.
I get better production. So I'm keeping my fingers crossed, hoping all 15 of my old 215s, bite the dust and I get brand new ones.
Absolutely.
Yeah, they used to want us to replace or to send them back. Now they don't care. Now they just say,
Okay.
yeah, keep it, toss it, whatever.
All right, cool. Thanks.
Yeah. And okay, so yeah, the Enphase system there. What I just wanted to show you is it does in fact generate at a higher voltage. So what is I went backwards. What is the voltage tolerance of an Enphase microinverter? And it shows here in their data sheet that the Enphase tolerance voltage is between 211 and 264. So my 245 volt, not a big deal. It's still operating within what they usually refer to as the MPPT voltage range. But if the voltage ever did rise above 264, my microinverter would probably trip some sort of breaker and shut down. I mean, the system, it just could not operate outside of that voltage range tolerance. Okay, so that's important to bear in mind when we're talking about SolarEdge or Enphase systems. Now, SolarEdge is another example, because these are really the two that are out there in the field, that the input range from the fixed voltage inverter, as far as I'm reading this, looks to me like it's 350 volts. That's its nominal DC input voltage. That was a little confusing to me because all the literature I ever read on SolarEdge always mentions 400 volts as its operating voltage, but this spec sheet is telling me 350. So that's what I'll go with. So when it reaches the inverter, the voltage has to be at 350. So what happens is the optimizers adjust the amperage so that they keep the voltage, in this case, at 350 volts. But it's got to be 350 volts when it reaches the inverter, not 350 volts when it leaves the optimizer. So if I had, say, 15 volts of voltage drop between the optimizer and the inverter, then that inverter would be generating at 365, and then it's received at the inverter at 350. So that's an important thing to remember. And what is the voltage operation, or the maximum voltage for these optimizers? And down at the bottom of this chart, 60 volts for most of them, 85 volts if you get the P405 optimizer unit. So they do have a maximum voltage tolerance. And what they do to maintain that voltage, or not to exceed that voltage when they're all in a string, is they have a minimum number in a string and a maximum. So for the single phase optimizers, typically with Enphase for this size group, when you're hooking together a string, it's 8 minimum and 25 maximum. So I would recommend for Enphase, if you're installing an Enphase system and you're talking about a long distance between where the optimizers are and where the microinverter, or not the microinverter, but the inverter is located. So I would say any distance greater than 100 feet, 150 feet, I would consider increasing that minimum. That way, as these things adjust based on low level lighting and low level or high temperatures or low temperatures, that you're not going to exceed that 60 volt output tolerance from your microinverter as it tries to compensate for voltage drop. So if I were designing a system that had a long run, I would change that minimum string to 10, for example, as opposed to 8. So that would be one design criteria. And just to give you hopefully a better understanding of the issue of voltage rise, I tried to put in an example using the 12 gauge cable. Let's say you're going to use 12 gauge cable on an Enphase microinverter system, and you've got a grid range, the grid range plus or minus 6%. Well, it could, and that's still within its tolerable operating range. So let's say that your grid all of a sudden spiked up to the maximum, 254 volts. Well, it's supposed to be nominal 240, but it can go up to 254 and still be considered working properly. And if you had that 12 gauge cable in that 150 foot run and it had an 11.85 volt voltage drop, then then the inverter output would have to compensate for that 11.85 volt drop. Plus it needs to match whatever the grid is operating at. So it's going to be at 254. So my inverter output has to be 265.8 volts to match the grid. And the Enphase tolerance levels are between 211 and 264. So at that stage, when that grid voltage spikes up, my inverter is going to shut down. It's going to disconnect. Now it will wait, look for the grid signal, and then go through a 5-minute handshake and then reestablish connection. If the grid voltage has dropped back down, then it's probably going to operate normally at that point. But if you were experiencing this where the inverters seem to shut off periodically, then reestablish connection, it may be a case of voltage rise. And that the grid, because of the fluctuations of voltage on the grid, you're starting to see your microinverters kick off. And the best solution there is to avoid the problem by putting in big enough cable. So if we put in big enough cable, 10 gauge in this case, or 8 gauge or whatever, then the voltage rise would not have been an issue. So that was just a scenario to talk about how voltage drop, voltage rise, all of those kind of things. So anyway, this is an item that people have been bringing up this week. Thought I would share it with you. Anybody have any comments, questions, or additional issues?
So Jay, if
Yeah.
you kind of like future think, okay, I'm going to live in this house for like another 20, 30 more years, right? Would you make the wire bigger?
Yes. I would
So
make the
that
wire as big as you can afford,
because
within
of future
limits.
prices?
Yeah. Yeah, you never get in trouble putting in bigger wire. You only get in trouble putting in smaller wire. And it may be that you'll never use it. Well, then you just wasted a little bit of money. That's the only issue. But we seem to be getting so many new innovations, that you may be going, you know what? I want to now hook up my car charging station to this thing or whatever. I don't know even what it's going to be, but having that capacity is awfully nice. When we talk about future proofing, if I'm running wire, even though my solar array at the moment is only this size, I think you should plan all the wiring for the maximum size that your roof can handle. Let's say that you've mapped out your roof and it can handle an 8 or a 10 kW system, but you're only installing 4. I would wire it for 10 kW, maybe even a little bit bigger, because there's going to be efficiency innovations in solar. Because you may in the future decide I want to add to that array. And now if the wire's already there, you don't have to pull out all the wire and rewire the thing. Of course, if you're burying cable, it's always nice to have an extra conduit in the ground, that you can fish additional cable through so you don't have to tear things up. All of those kind of things are nice to do, but they do add cost to the system. Okay. Any other questions there?
Hey, Jay, it's Wally here. Can I add one
Yeah.
thing to what you just said? So,
Sure.
so we're building a house down in Nashville, Indiana, and it's going to be like a passive type home. And the solar system that we're designing and Jay's helping us with it, our PV system, it's all going to be integrated together from an efficiency and light perspective, et cetera. But what we're doing is we're actively running additional conduit that'll be dark, to future proof it, right? To the point that was just made. And we may or may not use it. We're not sure yet, but it's good to have it versus having to bust up a slab, in a house. So I think, Jay, you bring up a good point. It's future proof it to the best of your checkbook's ability, right? Or something like that.
Yeah. And it brings up the issue of like last week when we were talking with Tony about electric vehicles, trying to understand where this equipment will have to be located so that you can then run conduit to it is not always easy, and it's not always straightforward. And of course, all these innovations, it reminds me when we built our Earthship way back in the early 1990s, and I was involved in telecommunications at the time. So we decided, you know what, we're really going to future-proof this place. We're going to put coax and fiber and Category 6 twisted pair cable, and we're going to run it to every single room. And we have these little jacks, and in the utility area, we've got a patch panel for all this stuff. And we did it, and we spent a lot of money, and everything in that house is wireless, all the communication systems. Don't use any of that infrastructure because the industry changed, in the intervening years. So you do run that risk, but it still makes a nice story. And you can always, who knows, if you've got extra conduit, maybe you can run water pipes or something under your driveway or something. You can still use the conduit for something. But yeah, it's never a bad thing to just think it all through and think, what might I be able to use this for in the future, or what, so put in bigger wire. You never get yourself in trouble.
Hey, Jay, not to go all prepper and apocalyptic here, but what are we seeing out there from an EMP protection or hardening perspective with the technology?
Yeah, there is some discussion about that. Of course, the EMP, the electromagnetic pulse thing that could, if somebody sets off a nuclear device in the atmosphere, but more practically, I think we've seen solar flares that literally could destroy, all the electronic devices. To my knowledge, and somebody else may have better knowledge on that, Solarc is the only manufacturer I'm aware of that actually builds in military grade EMP protection on their equipment. And because I think their base is quite a lot of preppers. It's mostly standalone systems. I don't know, Don, I don't know if Don's on here or not. He's got one of those systems installed. Anybody know of any other EMP hardened solar products? No, apparently not. So if you're worried about that, I knew a guy who would take his laptop and put it in a Faraday cage every night, and that gets a little crazy because I was saying, okay, so your laptop's fine. What are you going to connect to? Who are you going to talk to? So I don't know.
Well, Jay, we can just wrap our houses in aluminum foil, right? And walk around in spacesuits and we'll be good. So
yeah, well, the big problem there, and when I was looking at it for one of my textbooks, really it's got to be, as you say, wrapped in aluminum foil and not connected to anything, because any wires coming in is like a electromagnetic pulse magnet. It's going to just follow in the wire. And, so you really need some sort of pathway to ground for the pulse to be dissipated away from the sensitive electronics. So it could be a big issue. I mean, we saw electromagnetic pulses back in the days of the telegraph that literally blew out telegraph wires, and our systems are much more susceptible than those early crude communication systems. So, any other questions out there? Going to give you just a second. All right, everybody's being very mellow. All right, well, guys, hopefully this was helpful, and we'll call it a day, and we'll see you guys all next Tuesday. All right, take care.